So here we're going to use sodium acetate and acetic acid to show you the relationship between Ka and Kb. So sodium acetate is a salt, which means it's going to be a strong electrolyte in solution. So we're going to have a full dissociation to Na plus C2H3O2 . And this acetate ion is going to be the conjugate base of HC2H3O2, or it's the conjugate base of acetic acid. So that means if we take this particular salt, or this particular anion, and we place it in water, it's going to be in equilibrium with HC2H3O2 plus OH minus. Okay, so remember it's a conjugate base, so it's going to produce OH minus ions in solution. So I can write a Kb expression for this of HC2H3O2 times OH minus divided by the concentration of C2H3O2 minus. So here's our Kb expression. Likewise, we can write a Ka expression for acetic acid. Acetic acid is HC2H3O2 plus H2O liquid in equilibrium with H3O plus C2H3O2 minus. The Ka for this particular expression is going to be the concentration of H plus times C2H3O2 minus divided by the concentration of HC2H3O2, or acetic acid. So what happens now if I take Ka and multiply Ka times Kb? Okay, our Ka expression is going to be the concentration of H plus times the concentration of CH3O2 minus divided by the concentration of HC2H3O2. So this is our Ka. Our Kb, on the other hand, is HC2H3O2 times the concentration of OH minus divided by the concentration of C2H3O2 minus. If we look at these, some of these will cancel. Our acetic acid concentrations cancel, our acetate ion concentrations cancel, and we have a Ka times a Kb is going to equal H plus times OH minus. Now this expression right here should be familiar to you, because remember, this is what we refer to as the Kw, which is going to equal 1 times 10 to the minus 14. So the key relationship that we're going to see here is we know that the Ka times the Kb is going to equal the Kw. And this will allow us to relate Ka and Kb together, and we can see that this is going to equal the Kw. So just as we were doing calculations with concentrations of H plus and OH minus, we can multiply the Ka and Kb together, and we know that if we have a really large Ka, the Kb is going to be small, and if we would have a large Kb, the Ka would be small. So the key relationship here is what I've written in this red box. The Ka times the Kb equals the Kw, and we can derive that by looking at various expressions between, in this case, a weak acid and its salt. So you're going to be able to use this relationship when we talk about various salt solutions.